We know how to do, okay, this is a system of linear equations. The reason we call system equations is we got two equations and both are linear equations. We got two variables here. So now, if you graph this equation, you'll get the line. And if you could grab this, you get another straight line. So when the two lines intersect, that is a point which is the solution to this system equations. That means whatever this x has to equal to this x and this y and equal to this y. Okay, so how do we solve it? Now to solve this one is we're going to use a very fundamental technique for solve any math equation is that we're going to reduce it to something we know already. Like we know how to solve one variable linear equations. So therefore, we're going to reduce that two variable into one variable problem, then we can solve that way. So in this case, then we have to decide which variable we're going to get rid of. And when we say something get rid of, we have to follow the rules. And there is a very important rule in algebra is if A is equal to B, then A plus C is equal to B plus C. And this will A minus C is equal to B minus C. Okay. So therefore we can add or subtract equal amount on both sides of the equation. So this is a fundamental rule of algebra. So now want to get rid of one vex, we can change this one to its equivalent form. So what we're going to do that, we're going to times 2 on both sides of this equation. So we got 2x plus 2y equals to 70. Now, this is this property. If A equal to B, then A times C equal to B times C. As long as the equation, we can multiply the same amount on both sides. Yeah, which actually is application of this rule because the multiplication basically just adding many times. Okay, now we have that. So now we change this one to this equation. So then we can use this equation minus the bottom equation. So that's this rule. So now you can see that 2x minus 2x, that cancels, so it's gone. And 4y minus 2y, so those are 4y minus 2y, you got 2y. The 94 minus 70, that gave us 24. So simple subtraction. Now on this one, now we change that into a one variable problem. So that is pretty easy to solve. So divide by 2 on both sides, then y is 12. Now we got 12, then we have to go back. Either go to this original equation or go that. Then this is a lot easier, so we're going to use that. So then we substitute the y value. Now we know the y value. Plug that in here. So we got x plus 12 equals 35. And that, again, it's a linear equation, very simple, which is minus 12 on both sides. Then our x is equals to 23. So now we saw on both x and y. Now there is one more process is to verify. How do we know we got right? Now to know if we are getting right, we'll go back to original equation. So that's what we start with. So the reason we go back to original is in between, we might make some silly mistakes. So go back and let's check. Now we know x is 23, y is 12. Then add together, it is 35. So we know works for this equation. Down here, 2 times 23 plus 4 times 12. That gives us 46 plus 48, and that give us 94. So therefore, which is the same. So basically the left-hand side and the right-hand side are the same. That's why we say that equal. So therefore, as long as the same on both side equation, then we know our solution. In this case, x equal to 23, y equal to 12 is the true solution. Okay, are we good on this one? Okay, very good. So I'm going to show you another, and then if you haven't done this yet, just finish the rest. Okay, I'm going to pick this one. We got 2x plus y equal to 20, and x minus y equal to 1. Now, same thing, we need to get rid of one variable. And really up to us how to do it. As long as we follow the rule, remember, we said if we have an equation, then we can either add the same thing or minus the same thing or times the same thing, or this is B, or divide by the same thing. So that's all we have. There's just four things we can do when we have equation. So in this case, we notice that if I this equation add this equation, y got canceled because y minus y 0. So we do that. So we add the top plus the bottom, add the top and the bottom. Now this is different from early on this problem. We did actually one equation minus the other equation. Here we just add them. But the idea is the same. The goal is the same. We want to change the two variable problem into one variable. So we add them 2x plus x, 3x. And the other side, 20 plus 1, 21. Now we're going to divide by, remember, there's just four things we can do, right? Add, subtract, multiply, and divide. Divide by that, then that cancel, then x is 7. So that's our x. Now we're going to find our y. We can plug into here, which is 7 minus y equals to 1. And then in this case, we know y has to be 6 because 7 minus 6 is 1. So we got this. Then we can check. If we plug in the first one, x is 7, y is 6, it is 1, so it's good. On the top, 2 times 7 plus 6, which is 14 plus 6, which is 20. So we know we got it right. Okay, are we good on this one? Yeah, Roger, we good? Very good. Okay, so now the next one is this. We are going to use substitution. So there's two ways you can do system equations. One is elimination, another is substitution, but the goal is the same. We're going to change a two variable problem into a one variable problem. So for example, let's say this one. Well, pick this one. This is a simple one. We got x plus y is 20 and x minus y is 4. Remember, if we just do elimination, we just add the bottom. That gives us 2x equal to 24, then x 12. Pretty easy in this case, using elimination. But sometimes it's easier using substitution. Now, in this case, we can see that we can change this one to x equal to y plus 4. So basically, we add y on both sides. We got that. Once we got that, then we can see we can substitute this one to the other equation here. So what we got? Then we know x is y plus 4. So it's y plus 4 plus y equals 20. Then we got 2y plus 4 is 20. Then 2y is 16. Then y is 8. When we got that, then we just plug in back to here. Then x is 8 plus 4 is 12. So we find that our solution. Same thing we can check. 12 plus 8 is 20. 12 minus 8 is 4. So we know we got that right. Okay, are we good on this one? Mia, any question here? Okay, so you can see that different technique, but same goal. Okay, I'm going to pick another one. Let's see if I pick the third. We got 2x plus y is equal to 15, and x plus y is 5. Now, if we use elimination, actually pretty easy. Top minus bottom, we can get it. But here we're using substitution. So we're going to use x is equal to, we minus y on both sides, is minus y plus 5. Then we plug in this into the other equation. And so we got 2. Our x now is minus y plus 5. That's why it's called substitution. We substitute x with y, and plus y equals 15. And here we got negative 2y plus 10 plus y equals to 15. Then we got negative y, because negative 2y plus y, negative y plus 10 is 15, then minus 10, and minus y is 5, and y is negative 5. Once we have that, then we can plug in, I'll make sure we got things right. Got x equal to negative y plus 5. Then I plug in on the top, 2 negative 5 plus y plus y, 2, 10y, and minus 10, 5, or it's y. Okay, and then we can plug into here, which x is minus 5, because it's minus y is negative 5, plus 5. Then we got 5 plus 5 is 10. So we got x is 10, y is negative 5. Then we can plug in. If you plug in the bottom here, it's easy. 10 plus negative 5 is 5. So we know we're good. On the top is 2 times 10 at negative 5, which is 20, minus 5 is 15. So it's good on top too. So we check on both equations, and our solution basically we call satisfy both equations. That means if you plug in, both equations are true. So that's why we see that is the true solution. We didn't make any mistake here. Okay, are we good on this one? Thank you, Grayson. Thank you, Mia. Thank you, Mason. Rondre, you good? Okay, very good. So let's looking at the XY coordinate plane. Then we're going to graphing linear equations, and then we use graphing to solve system linear equations. Okay. So this one is to find the middle point and slope point. We know the middle point solution formula is x1 plus x2 over 2, basically the average of both x coordinate, then y middle point is y1 plus y2 over 2. And the slope is rise over run, which is the difference in y, we use delta y over delta x. So for this problem, let's see, our slope is the difference. You can write as this, 4,9 over 1,3. So 9 minus 3 over 4 minus 1. So we got 6, we got 3, that's 2. So our slope is 2. Now our midpoint in this case is 1 plus 4 divided by 2. So it's 2.5. And ym is 9 plus 3. So if you line up like this, it make things easier for you. Divided by 2, which is 12 over 2. So that's our 6. So now that's how we got. Our slope is 2. Our middle point is 2, 2.5, and the comma 6. Now, if you're graphing it on the graph paper, you can see that's the case. Okay, are we good on here? Yep, very good. I'm going to give another example. Let's pick this one. So same thing, I'm going to put one on top of each other and 4, -9. So we know that the average, the midpoint is the average. So -2 plus 4 over 2. That's 2 over 2 is 1. And that is 3 plus -9 over 2, which is -6 over 2, give us -3. So our middle point is 1, comma, -3. Now, if you plot this on XY coordinate, you can see that the middle point is indeed 1, comma, -3. Now, our slope, right, that's m, and that gives us 3 minus 9, 3 minus -9 over -2 minus 4, and that gives us 3 plus 9 over -6. That's 12 over -6, that gives us -2. Yep. Okay, are we good on this one? Yeah. Roger and Mia, are you good? All right. Okay, let's do this. Graphing the linear equations. So graphing linear equations, it's actually pretty simple. We just need 2 points. And the 2 points is really up to us how to make them. This for example, for this one. Now, if x is 0, we know y is 0. And if x is 1, then 2 times 1 is 2. So that's how we find 2 points. Now, once you got 2 points, all you need to do is just use ruler to connect. That is 1 point, -1 and 2, 1, comma 2, then just connect them. Pretty straightforward. Now, if you want to pick this one, we have xy, and if x is 0, then y, of course, is 3. Now, we're going to pick, since the 2 points, up to us how to pick, we're going to pick something easy for us. So in this case, I'm going to pick 3, because -2, 3 times 3, that gives us -2. -2 plus 3, that's just 1. So if we do that, I do 3, and we got 1. So then we're going to graphing it. Let's say using different color. We got first one, 0, comma 3 will be here. That's our y-intercept. And we got 3, comma 1. So 1, 2, 3, comma 1 is here. So if you're graphing it, you got this line. Yep, good. Okay. Mia and Roger. Yeah, Roger, are we good? Okay. So now with that, we got into solving systems of linear equations by graphing. So both of them, we actually see 2 kinds of linear equations. One side is y, and others then the other side is x and the number. Then we could say something like x plus y equal to 10. And that is different form a linear equation. You can see that. On this one, y is on the left-hand side, everything go to right. And this is something we call slope-intercept form. And on this side, both x and y is on the left. Then we have a constant on the right. This is called standard form. Now, what you can do is, in order to graphing it, is same thing. We just need to pick out 2 points. Let's see. Let me give let's do the first one. And we go x and y. Now we can give, say, if x is 0, then we can see that we got x, y equal to 10. One thing you can make your life easier is to change this to slope-intercept form. Basically, minus x on both sides. You can see that y is minus x plus 10. So if x is 0, then y is 10. Now, if x is, say, 1, then y is 9. And so then you have graphing. And make sure you got that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here. Oh, sorry, here. And next point, this is 1 down here. So that's a line go down like that. And then we're going to find this one. So this is x minus y equal to 2. And we can write as negative y equals to 2 minus x. Then we divide by negative 1 on both sides. Then y will be negative 2 plus x. Yeah, so we got that. Another way you could do, remember, you got 4 ways to do it. Add, subtract, multiply, divide. And it's really up to you how, whatever way you want to do it. So in this case, I can just add y on both sides. What we got is 2 plus y is equal to x, then minus 2 on both sides, then y is x minus 2. So knowing that, I got 2 points. When x is 0, our y is negative 2. When x is 1, or I can make x equal 2, then 2 minus 2 is 0. So I got 0, negative 2 here. That's 1 point. Then 2, 0 will be here. And then we got a line going like this. Somewhere the intersection is the solution. Well, let's see. Looks like we'll add 1, 2, 3, 4. The height is 4. And 1, 2, 3, 4, 5. Looks like 5, 4. Well, we'll be a little bit off because the way I'm graphing it is not exact. So you can see that if we plug in 5 plus 4 is 10, 5 minus 4 is 1. It's not correct. So this one, most likely, this should be 6. The reason I'm off is because I'm not using a rule, graphing paper, not using a ruler. So that's what I got. Why it's off. But once I got it right, then I'm fine. So are we good on here?
I'm kind of confused.
Which part?
How you like do the graph, like with all the numbers and stuff.
Well, when you're going to the graph, all we need to do is find 2 points. So for example, when we have this, and we just need to pick two numbers. Now, if I rewrite like y equals to minus x plus 10, so basically I change this form to this. The reason we do that is because earlier we did that, not a lesson, we used this form. So that's something we have to do. So in this case now, if I put X and Y, really just 2 points. If I put X is 0, then Y is 10. If I put X is 1, then I got 9. Or you can put it like X is 5, then negative 5 plus 10 is 5. So doesn't matter how you got 2 points. What matters is you got 2 points. Once you have 2 points, that become we just find 2 points and connect them with ruler. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got here. Then I got 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 will be right here. So we got a line like that. Good.
Ah, okay.
So that's how we're graphing it. Okay.
Okay, thank you.
All right. So I'll let you work on number 2. Okay. So you just tell me the solution, but please use the graphing paper and the ruler, and otherwise you're being off. Okay. And I'll be right back.
Trying to get to Unreal. I can brag it all my friends, and I'm doing math class, so it's better than just sitting here and doing math class.
You know, it's I would call like hyper grace creatures.
Good job, Roger. Now, if you don't use a ruler and a graph paper, then it's easy to make a mistake.
It was so distracting.
Hey, Grayson, do you need more time?
Is it 1 second?
Mm-hmm. Mm-hmm. Very good. Good job, Mason. All right, so let's know how to do that one. First of all, we are going to change that. If we add x, so that way when we have y on the left-hand side, y is x plus 3. And that allows us to get 2 points. Xy, x is 0. Then 0 plus 3 is 3. We got the first one. If x is 1, and then y will be 1 plus 4, 3 is 4. But if we got those 2 points too close, it's easy to be off. So one of the technique you can do is to make that a bit further away. So instead of 1, you maybe want to take, say, 3. And in that case, now our y is 6. So we got the first line. 1, 2, 3. Make sure. And we got 1, 2, 3. We got that's 3, 4, 5, 6. That's here. So we can connect that. And the other point then is this, which is y plus x equal to 7, then minus x on both sides, then y is minus x plus 7. So if you want to put a point, if x is 0, then y will be 7. And let's say x is 4, then we got 3. Because negative 4 plus 3, plus 7, that's 3. Okay. So 0, 7, 1, 2, 3, 4, 5, 6, 7, we got here. That's our y-intercept. And 4, 3, 1, 2, 3, 4, 1, 2, 3 will be here. And then we got connection here. So what will be the number here? It looks like going down is about 2, going down here is about 5. Okay, so it says 2 comma 5. Well, we just plug in to the equation here. First one is y minus x equals 3. If y is 5, x is 2, 5 minus 3. So that works for the first equation. Second equation is y plus x, so 5 plus 2, that is 7. So therefore, our answer is 2 comma 5. Good. Yeah, thank you, Mason. Yeah, make sure also the XY coordinate get right. Roger and Grayson. Okay. Grayson. All right. So I have you do the next one and see what you got. Good job, Mia. Good job, Robbie. Good job, Mason. Mhm. Hello. Hello. Uh, can you hear me? If, okay.
It's working now.
All right.
Sorry.
No problem. Something happened. Okay. Well, good job, guys. Grayson, what's your answer?
I'm working on it. Sorry.
Okay, that's fine.
Poor prognosis because it does not usually create any type of symptoms that people notice until like
Because he's been using it. I don't care. Using it non-stop. I don't care. Okay, I drop these ones. 0.5. Is it 1.5, 2.5?
Yep. Very good. Very good. So we got, oh, so negative x plus y equal to 1. So y is x plus 1. Then we got 0, 1. Oh, sorry, x, y. Then x is 0, y is 1. Then we can say x is 2, y is 3. And the other one is x plus y equal to 4. So minus x on both sides. Then y is minus x plus 4. So we can have xy 0. That's 4. That can make 4. Negative 4 plus 4 is 0. So I'm trying to make that a little bit have some distance between the 2 points. So now we got for the first one 0, 1 and 2, 3. 1, 2, 2, 3 will be here. So that's one line. The other one is 0, 4. 1, 2, 3, 4, and 4 comma 0 here. So it's going down like this. So you can see that this point is close to 1.5, and because I'm not graphing with correctly, so I can off, but I can always check back in here. If my x is 1.5, then negative 1.5 plus y equal to 1, then y has to equal 2.5. And 2.5 plus 1 point is indeed 4. So at least give me the ballpark. But if you use the graphing paper and ruler, you can get that very pretty accurately. Okay. So let's do one more, okay? Then the rest, you can do that at home. So get that done, okay? Number 4, let's see what you got. And you can also check. You plug in and see if that's correct. Good job, Roger. Good job, Mia.
Sorry, which one do we do?
Number 4. Good job, Mason. Good job, Grayson. Very good, very good. Good job. Okay, well, we have some more time, so let's finish them here, okay? Let's do number 5. Good job, Mia. Good job, Grayson. Good job, Mason. Yeah. So this one is 6, 3. Very good. All right, let's do the last one. So you don't have to send me this, but you can do finish the other homeworks. But this one you consider done. Job, Mia. Oh, actually, good job, Mason. Good, Roger. Mia, thank you. The coordinate is off. It's other way around. Very good, Mia. Mm. Roger, do you need more time? Oh, sorry, Roger already did. Grayson? Hello, Grayson.
Yeah, I think I sent the answer.
Do what?
Sorry.
No, that's fine. All right, so let's look at how we do this one. We can change y equals to x plus x, right? And so we got x, y. When x is 0, y will be 6. Now when x says 3, then y will be 9. So really depends on, up to you what kind of 2-point you got. But 0, x to 0, the y-intercept is a good point because it's easy. Then I look at the other one, which is 2y plus x equals to 15, then minus x both sides. So 2y will be minus x plus 15. Then we're going to divide by 2 on both sides. Now we change that y equal to negative half x plus 15 over 2. Now, if you want to set x to 0, then we got 15 over 2, which is 7.5. Now the other one, if I pick them, say, as say 4, then I got, then y will be negative half times 4 plus 15/2. This will be -2. 15/2 basically is 7.5. So that give us 5.5. So now we can just graphing it. We got 2 points now. And one is, so when you have graphing paper, actually it's pretty simple. And if you're just in like 0.5, and that's actually pretty easy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6. That's our y-intercept. And 3, 1, 2, 3. We got 6, 9. So 6, 7, 8, 9. So somewhere here. So we got line go like that. And then here we got 0, 7.5. 7.5 will be here. And we got 4. 4 is here. 5.5. 1, 2, 3, 4, 5. 5.5 will be here. So that's line goes there. So you can see that this part is kind of close to 1 here. And this side is 7. And so 1, 7. Then we can check. Back to the y minus x. That's 7 minus 1 is 6. And our right hand is 6. That's good. And for the second equation, 2 times 7 plus x, which is 1, that's 14 plus 1, 15. So you can see that with graphing, with using graph paper, you can easily solve this equation, the system equations. So basically on this, what we learned so far is we have 3 different ways to solve system equations. We can use substitution, elimination, and we can use graphing. Okay, are we good? Thank you, Mason. Thank you, Raji. Thank you, Grayson. Thank you, Mia. Very good. I'll see you guys next week. I'll send out the quiz today, okay? And make sure you have 1 week to finish, but make sure you finish the homework before you take the quiz. Good.
Okay, thank you. Bye.
Bye.